Today we are speaking about systematic innovation. Innovation is the art, you could say, of inventing something new, something that doesn't exist. In particular, new solution for problems. Now, let's imagine that all that we know can be inscribed in a circle, and what we don't know is outside, what we have to discover, innovative ideas. Now, we don't know which is the best path to reach our solution, the solution to our problem. We don't know because we haven't found our solution yet. Which is the best way to find our way to the solution? Well, a first option is the so-called infinite hypothesis method. Was mentioned by Robert Pirsig in his famous book Zen and the Art of Motorcycle Maintenance. He says that when we are facing a problem, by logic, we should keep in consideration an infinite amount of hypotheses of solutions. And that is impossible. Intuition has to come in some moment of this experience. Another option is the John Nash one. He was famous because he was capable to focus on a problem, just looking at the set of equations that they had to solve, and then he popped out with the solution, with just one giant step. Now, which is the way in between that we can use to find our optimal path to the solution? Because obviously we can consider infinite solution, and we can consider just an intuition that can bring us the solution in one step. Well, somebody found a method to organize our process in a systematic way with small steps in the optimal direction to the solution. This technique, it's a theory, it's called TRIZ. It's a Russian acronym that stands for Theory for Systematic Innovation. And it's based on the fact that evolution in technology follows some paths, some particular paths that can be detected and described, like the evolution in nature. In technical problems, we face most of the time contradictions. What is a contradiction? It's better to give you an example before. In a technical system like this, where we have a mechanical component, we would like to have resistance, but also to have a very light component, to use less material and to spend less resources to move it. Now, the fact is that if we have a too light component, it can break more easily. This is a contradiction, because we have a physical parameter that in this case can be the thickness of the component, that influence two different engineering parameters, the weight and the strength of the component itself. A more precise scheme is this one, where we have a control parameter, something on which we can act directly, that influences two different characteristics of our system. Improving one, we act in a bad way on the other, and vice versa. This is a contradiction. We have a problem, an administrative one. We have to make a mechanical part more resistant, but also lighter. This can be described by a physical parameter, a distance that can be measured in millimeters, for example. And this brings us to a finite set of problems, because the engineering and physical parameters are not infinite, because they correspond to physical quantities. history and analysis of invention has brought us a series of inventive principles that can guide us to the solution. Althusser, the founder of TRIZ theory, made a matrix 39 by 39 where he lists all the possible situations where we can find variations of engineering parameters that make contradiction, and a list of 40 ways to solve them. Through this method to solve technical contradiction, we can find a scheme for find a solution for physical contradiction, because all of these methods listed in the 40 principles can be in some way encircled in physical contradiction solution. The most important is separation, that we will analyze soon. Satisfaction is the solution of the contradiction without using a compromise between the two quantities, and usually involve a totally new technology. Then there is bypass. That means to avoid, to front the contradiction, to find another way in which the contradiction stays there, but it doesn't matter. Now, focusing on separation, it's one of the most interesting. We have 4 ways of separate our contradiction. What does it mean? It means that our contradiction maybe is not present in all the space that is interested by our system. Maybe it's not always present, for a matter of time. Or maybe it's present only in some condition in which our system operates. Or, in a more sophisticated way, it's present in between the macro level and the micro level of our system. Once we have analyzed our contradiction, we can understand in which level we can operate, in space, time, condition, or macro and micro. We can come back to inventive principles, and we can find the best path for solve our contradiction. For example, in space, the problem of the mechanical component. We don't need that the thickness is equal in all the space occupied by our component. So we can divide the space where the thickness is important from the space where it isn't. In time, maybe the complexity or the capability of our system can evolve dynamically during the operation to change the characteristics that are more suitable for that phase of the process, like for the space shuttle. Condition. We can have a chair that changes shape, that is small and that occupies a small space when we don't want to use it, and then that it's comfortable and offer a lot of seats for many people when there is the need. And then the micro and micro level. We can look at the track of a tank, for example, or an excavator, and every single element of the track is rigid and very resistant. But if we see all the system, it is very flexible and can easily adapt to the terrain. Now, this was just an introduction to the concept of separation and the guided solution through a systematic path designed by TRIZ. What we can learn by this experience is that contradictions are seen like a wall that stops our progress to innovation. We have changed our point of view and our system of analysis of the problem and see them as the path that we can use to walk through our solution. But more important than that is that every one of us can do it. Because we don't need to be a genius like Nash. Everybody of us can become creative with this method that can guide us to a totally new path of innovation.